Before we jump into curly, let's remind ourselves about S expressions in Plait. The reason we're interested in S expressions, remember an S expression is how we represent a program in concrete syntax, but also it's the way we think about sugar. For example, we think about let x be 6 and x as being rewritten at the S expression layer to lambda x return x applied to 6. We started changing parse to take this sort of S expression, change it to this other S expression, and then call parse again on that S expression. So we're interested in manipulating these S expressions and generating S expressions. When we have an X expression, like 1, 2 in a sequence, that's analogous to a list that has 1 and 2 in it. The difference between a list and an S expression, though, is that an S expression can have mixed data, like the number 1 and the symbol x, whereas if we try to make a list containing 1 and x, it doesn't work, not even if we try to use the quote shorthand. So that's why Plait, and especially Plait's type system, needs a distinction between lists and S expressions. But there is still a correlation. When I have the S expression 1, 2, and I want to get the 1 out, then I want to use first on the list structure of this, but I can't use first directly because it's not a list, it's an S expression. So we have to convert the S expression to a list if we want to get it into the list world where we can use first. Another place where these coercions show up is when we use unquote, a comma, under an S expression. So remember that unquote escapes so that we're back in the expression world now. And if I want to put an x there, I could almost do this, but the problem is unquote needs to produce an S expression to go in place of the comma replace thing. So I would have to change my symbol to an S expression explicitly to put it right there. Okay, and you can see this can be a complicated expression right here. I could do if true, return x other than y, else return y, and I'm still going to get an x out from this because comma escapes to the expression world. That expression produces an S expression, and then it's put in place of the comma and that expression in the S expression. And this comma notation is especially useful if we have it deeply nested in some other big form. Then we don't have to reconstruct everything. We can just drop down in the middle of that and add some substitution using comma. So that's a refresher on S expressions and lists in Plait. But this notion of S expression actually comes from an untyped language. It comes originally from Lisp and then goes through Scheme and Racket. And there, when we write an S expression, like 1 applied to 2, you can see it prints the same as a list 1, 2. That's because there's no distinction made. I can take the first of 1 applied to x, say, and I'll get the number x out. And I can take the second and I'll get the symbol x out. There's no distinction between the S expression x and the symbol x. And I can still use escapes. So I can escape to put the symbol x there, or let's do a more complicated expression. And you'll notice I don't have to do any coercions from symbols to S expressions. They're both the same, and so I can mix them together. So this is all relevant. This untyped view is relevant because we're going to add a notion of S expressions to curly. Curly is currently an untyped language, and we're going to not have to distinguish between S expressions and lists and symbols and so on. And that will make it more convenient to manipulate programs to implement sugar within curly itself.